Give it up for Matthias.
Hi, my name is Matthias Rella. You can find me on the web, on GitHub and on Twitter. Anybody knows which mountain this is? Yes, exactly. Schneeberg, yes. That's where I live with my wife and 2 kids. That's where I also run my business, developing data management and data visualization apps. And I'm doing this for about a year. And I'm using Elm for this in production. And I'm very happy with it. I love it very much. So Nick and Patrick asked me whether I could give a talk on Elm on this React meetup. And yeah, my first intention was to talk about the good, the bad, and the ugly parts of Elm, some abstract topic. Yes, and last Saturday, when I wanted to build up the presentation, I thought that I would use Prezi for this because I like Prezi. And then it came to my mind actually that Evan, the creator of Elm, was working at Prezi for some time, and he was working there on Elm, actually full time. But when you look at Prezi today, it's still based on Flash. So there's no Elm code running in any Prezi presentation. So I wondered whether I could build a Prezi-like presentation framework in Elm. And that's what I'm going to show you today. It's called Dive. And it was really easy to do it because Elm comes with so many powerful abstractions for building reactive and interactive and also visual applications that it was really easy. And I want to show you today some Elm code. Don't worry, Elm is really readable and visual programming language. And I want to demonstrate you why it was actually easy to do this. Source code is online on GitHub. I'm going to make a release next week. Yeah, and guess what? This presentation is built with Dive. So let's dive in. Okay, every Elm program starts with a main function. It's the main entry point. And Elm has kind of a middle layer, which are effect managers. And HTML program is such an effect manager. It's a function. Everything is a function in Elm, by the way. And HTML program takes this record, which describes a full Elm architecture. You might have heard of the Elm architecture. It consists of a model, a view, an update, and also subscriptions. And the model is our application state. The view transforms the application state into HTML. Update updates the model given a message. And subscriptions lets us listen for events and map them to 2 messages. So this is also the structure of my talk. First I will talk about the model of Dive, then the view, the update, and the subscriptions. Okay, let's look into the model of Dive. What's the data model for building a Prezi-like presentation framework? We need a world, which is a list of objects which we want to draw on our canvas. That's all canvas here, not SVG. We need frames, which tell us where we define into which part on our canvas we want to zoom into. And we have an animation state, which we need when we transit from one frame to another. Let me give you an example. Here we have 2 objects, a text object, hello world, and the image object, this world. And we have 3 keyframes, 3 frames, these red rectangles. Currently we are on the first frame, the outer one. And the second frame zooms us onto this hello world. And the third, which is you see, the smaller the frame gets, the more you zoom into the canvas. Let's just look at this world. So what do you need to write to get up such a tiny piece of presentation. You need to define your world, which is this list of objects. Here we have two objects, a text object and an image object. The text object gets certain parameters, the text, the color, the font, the size, the alignment, the line height, and also a position. And the image object gets the source to the image, the width, the height, and also a position. And there are other kinds of objects available for drawing polygons, rectangles, paths, and so on. And the second thing we need are these frames. In our example, we had 3 frames defined. Each frame takes 3 parameters, a position, a size, and the duration in milliseconds to transit from one frame to another. So here we define that transiting from frame number 1 to frame number 2 takes 500 milliseconds, from frame 2 to frame 3, 800 milliseconds. So actually that's all you need to know to build this kind of presentation. You can go now and build one for you. If you want to know more about how Dive works, you can listen now. So world is a list of objects. Then we have these frames. Frames is not just a list, it is a custom data structure I built mainly to enforce that we always have one current frame where we are onto. And we have 2 lists, a list of previous frames and a list of following frames. And by enforcing that, we always have to have one current frame where the compiler of Elm can check the whole application, that you always have one current frame you are looking onto, because that's essential for a presentation, that you have some kind of frame where you're focusing to. And finally, we have the animation state. This has a 0-1 relationship to the model, so there may be an animation. Namely, when we are switching from one frame to another, then we have an animation state. In all the other cases, we don't have an animation state. And if we have an animation state, this animation state keeps a value passed. It's a value between 0 and 1, which tells us the fraction that the animation has already fulfilled in kind of percentages. Okay, and target is a reference to a frame, the one we are moving to. Okay, we are moving from a current frame to the target frame. Okay, that's actually the data model. That's what it looks like in Elm code. Yeah, world is a list of objects. Frames is this frames type. And animation is maybe animation. So in Elm, we can explicitly say that something might be there, or it might not be there. Yeah. So if we don't have an animation, this is nothing, and we have to deal with it in our code. All the cases where animation could be nothing, we have to define what should happen then. There are no null pointer references, and a lot of bugs eliminated preliminarily. Okay, and the fourth thing is viewport. It's the size of the browser window. Okay, that's for the data structure. I think it's not too complicated. Let's look to the view, the view function. It takes a model and outputs HTML. So what does this function look like in detail? By the way, some words on the Elm syntax. Line number 1 is the annotation of the function, or contracts, as Elm calls it. So it defines that the input is a model, something of type model, and the output is something of type HTML. Forget about this message thing, it's not too important for now. So the return type actually is always the last type in this type annotation. Line number 2 is the function header, the function name plus parameter names, which we use in the function body. So in line number 3, we get the world out of our model, the list of objects, and pipe it to list map object to form. So object to form, a function is applied on the list of objects and transformed to a list of forms. A form is something which can be drawn to the canvas. It's not an HTML form you might think of. It's a form which can be drawn on the canvas. I'm using a graphics library which Evan himself wrote here, and yeah, he named it form for whatever reason. Then this list of forms is piped to group transform, also a function from this graphics library. This function groups the list of forms into one form and then applies a transformation matrix. The transformation matrix is calculated in line number 6 by this function transform, which also gets modeled as an input. We will look into transform soon. Line number 7 is an anonymous function. We need to put it in here because Collage expects a list of forms as its input. So we have to wrap this group form into a list first before we can proceed to line number 8, Collage, which actually draws, creates the canvas object. It gets the width and the height of our viewport and this group form, already transformed by this transformation matrix. And finally, toHTML turns the canvas object into an HTML element. And this is returned by this view function and displayed to the user. So let's look first into object to form. It takes an object and outputs a form. We have here one feature of Elm or functional programming languages is this kind of pattern matching. You can say if object, in case object is of image, you can decompose its parameter into, or the structure parameter into source, width, height, and position, and use these values in the body. Image, again, is a function from the graphics library, creates an image element. This element must be turned into a form. Don't care too much about it. Then we transform this form by calling move and moving it to the position where we want this object to appear on our canvas. And there might be other types, or there are other types defined where this kind of transformation is done. And now for the transformation matrix. The matrix defines how the objects in our frame should be scaled up to the viewport. And the question is, which frame do we use? So, one word again on the Elm syntax. Here we have a let in expression. In the let part, we can define temporary variables, make intermediate calculations, and use the values in the in part. So here we assign something to frame and use it then in the in part, and this one gets returned by transform. Okay, what is frame? Here we have model animation. We're looking into model animation. Is there any animation happening? If there's nothing, so we take the current frame. Like now we have no animation, we are taking the current frame. We frame the current frame. And if we have an animation, we're getting this animation state out of our maybe type and interpolate the current frame with the target frame, taking this value passed, which is available in 0 and 1. So 50%, for instance, the animation is somewhere in the middle. The current frame is somewhere in the middle between the current and the target frame. 100%, the frame is equal to the target frame. Okay. Animate is a function which does that for us. Some calculations, not too interesting. And finally, matrix does the actual calculation of the scaling factor between frame and viewport, and the translation vector between frame and viewport, and puts it into a matrix. And this matrix then transforms our forms, scales them up so that, yeah, we have that in focus, which we want to have in focus. Okay, that's for the view. There's not too much more to say about it. Now let's look into the update part, the messages first. And again, it's also a union type. We have a resize message type, which takes a parameter of the window size. We have a fourth message type, which gets no parameters. And we have an animate message type, which gets a time value. For the subscriptions, as I said, this allows us to subscribe to events and map these events to messages. So, for instance, window resizes is such a thing by the Elm, is contained in the Elm core packages. It subscribes to the resize event of the browser and passes this resize event, the resize value, the new size value of the browser, into our Elm program, and we can map resize onto this value. The same goes for mouse clicks. Mouse clicks emits the position of the mouse click where it happened, but since we are not interested where I click on my presentation to move forward, we just map this event as such on our type fourth. And the last subscription is a bit special one. This is a function, takes the model as input, and it returns also a subscription, but under certain condition, namely, if we have an animation again, then we want to listen to the animation, we want to get the animation frames from the browser. Animation frame.diffs hooks into the browser's request animation frame function, returns the difference between the previous and the current animation frame timestamp, and we map this delta value in our animate into our animate message. And if we have no animation going on, we use this sub none thing, which is no subscription essentially. Okay, is that somewhat clear? We only want to listen to the animation. We only need the animation frame if we have an animation. If we don't want to animate anything, we don't need to listen to it. Okay, finally the update function. It takes two parameters, a message and a model, the current model state, and outputs an updated model. So in case the message is of type resize, we can get the size value which is carried along with this message type and store it into our viewport of the model. If we get a message of type fourth, we want to move forward in our presentation, then we get the first element from the list of following frames, but since this list might be empty, list head returns a maybe type, a maybe frame, okay? So if the list is empty, we have nothing, so we are at the end of our presentation. There are no following frames, so we do not update anything. We just return the current model. Okay, so yeah. In just frame, if we have a frame, then we populate our animation state with it and say pass the 0, so we are in the beginning of our animation. And finally, the animate message type gets this delta value. Again, we have to ask, is there any animation going on? If not, we do nothing. We just return the current model state. And if we have an animation, we update the past value, applying this diff in relation to the duration the animation should take, the target should take. And if this new value we calculated is smaller than 1, then the animation is still going on. So we just update our animation state with this new value passed. But if the value passed is equal or bigger than 1, then we say we have the animation finished, animation is set to nothing. And frames is updated so that the target from the animation state is put into current in the model, and the list of following is the head of the list of following frames is deleted, and yeah, then we are on the next frame. So that's it. Here again, the Elm architecture, which wires everything together. The model, our application state, the view, which renders the application state on the screen, and update, which updates the model given a message. And the message comes from the subscriptions. So that's it. You can find the source code on GitHub. As I said, I'm going to make a release next week. Maybe polish the API a bit so that one can easily create a presentation like this. And yeah, you can make pull requests. I'm open for any discussion. You can ask questions now. I'm happy to answer them. Thank you.
How long did it take? Yeah.
What?
To make that.
To make the framework or this presentation?
To make the framework,
the core of the framework. I mean, I started with on Saturday. And it took me about
which year?
2016. It took me 3 hours to create the core of the framework. I mean, of course, there were some bugs and some details. You can look into the GitHub repository and look at the GitHub, the commits, timestamps. But of course, building such a presentation is a bit cumbersome without an editor because you have to play around, put the frame on the right position, reload all the things, go through the presentation all the time, and yeah, play with the values. Especially if you're very, very deep into the presentation, the values are somewhere fractions of one. Gets a bit cumbersome then. So an editor would be needed, definitely.
To build a presentation as a framework.
Yes, yes. It depends how big the presentation is. It's a normal size presentation, I would say.
I think it's a very similar experience as if you do a spectacle presentation in React. It's pretty painful as well. That's the reason why they made an editor for that.
Was the time delta in animation done automatically by Elm, or did you calculate that somewhere?
The time, what?
Delta?
It comes from Elm. There's animation frame diffs, but there's also animation frame time or timestamp, which gives you the absolute timestamp. You can take this one or this one.
And another question. If the most zoomed in font was like 10 pixels in size, then this would be like 1 million pixels. How is that managed?
It's all floating points, so the overall presentation must not be 1 million pixels. This actually is 5,000 to 3,000 something or so. But since everything is floating point, you can go to 0.0000 something. Okay. There were some tricky parts transforming this floating point into integers because this graphics library in some cases uses integers. So in the back, the details, okay, but they're solved with Dive.
And are other things taken out of memory when you send writing?
No, not yet. Actually, with my machine, it's starting to get a bit lucky or vocalic. Yes, there's potential for optimizations. Nick?
I couldn't figure it out yet, but like, what happens if you go trigger the action 4 while you're in an animation?
Yes, that's working.
Is that prevented? So, or
No.
does it like move then to the next one right away?
The code that I showed you is a bit simplified, okay? So this is not working with the code I showed you. I added not too much. It's not too much code that is needed to make that possible to. It's possible here, okay? I can go through the slides quickly. I don't have to wait till the animation stops.
So it's
I can send this force
the animation
message.
starts, and does this mean like if you click forth already to the next, then it tries to move to the next one already, or is it it's not in sequence, right? Or does
It just instead of finishing the animation, it takes the target, puts it right into the current, and yeah, that's it.
Yeah.
Actually.
Okay, that's cool. Yeah. So that was exactly my question. Does it like?
Yeah. It is that easy. Yeah.
Nice. That's good.
So, what was your main motivation to go with Elm with your newest projects?
As I said, I started with Elm a year ago, and I heard about reactive programming and those things, and I found it very interesting to work with streams. Found it more intuitive, better for building web applications. And then in a blog post I heard about Elm, and I liked it because, of course, of the compiler, because you're not writing JavaScript, you don't get this runtime stuff, errors, and and I'm always from the perspective, if I have a language for something, I can be more productive than if I have a framework for something. So I thought, oh, there's a language for reactive programming, so okay, I use that.
What was your background before Elm in terms of programming languages?
JavaScript, of course. I used Backbone in my master thesis, but I didn't want to use it anymore. I was looking for something new. If I hadn't found Elm, maybe I would have found React and Redux and these things. But I'm absolutely not into these technologies. I haven't just heard about it, haven't used it ever. Patrick told me there are some similarities in Redux and React with Elm. These kind of messages are similar to actions in Redux and so on. And they have surely a similar concept.
It's actually super scary. Who has been using Elm before? So just raise your hands. Okay. So a few people. So the thing is, what I really like about it is you have very similar concepts. For instance, like the update function would basically be our reducer, because you get a model, you get a message, which would be the action, and then you just do a pattern match, which cannot be tricked. Like the compiler knows, okay, you have these actions, you have to catch all these actions. And if you don't catch one, then the compiler tells you. So this is one of the things which I really like about Elm, that it prevents you from doing mistakes which you usually have in JavaScript. So I don't know, you have a default case where everything goes in and then it does anything, or you try to go into a switch for an action which doesn't have a specific attribute. Elm does it for you. So this is one of the really, really nice things about it. Also, since, as you said, like in the beginning, like the HTML program, it sets up an architecture for you, and which is basically what we know from, it's basically what we know from Redux, right? It's at some point. I mean, it's not comparable at all because everyone says there are no components and whatsoever, but for me, like in a mental model, it seems a little bit like Redux. Because you have your view function, you have like the init for just the initial state, which is called model. You have the update, which would be your reducer. And Elm does also force you to think a little bit smaller, like in very small focused functions, which makes it very easy to refactor things and to connect things in another way. And yeah, it's just, that's one of the reasons why I wanted him to talk here. because it's so important to see alternative languages, to get the ideas of different languages and frameworks and take advantage of it, because a lot of people get inspired with it. Also, Dan Abramov claimed, like said, that Redux was influenced by Elm architecture. So just keep an open mind for that, and yeah. Thank you very much for this talk. And if you have any more questions, just please go to him, and yeah.